Hello, today we are going to learn how to use the limit process to find the area of region bounded by a graph of a function, x-axis, and two vertical lines. This problem uses the limit process to find the area of the region between the graph of the function and the x over the given intervals. Sketch the region. Y equal x squared plus 2. Y equal x squared plus 2. The graph of this function opens up. It's just a parabola. It intersects y-axis at the point 2. Have a look at the graph of this function. If I want to find the shaded area, which is subtended between 0 and 1, the upper boundary is the graph of the function, and the lower boundary is the x-axis itself. First of all, we have to divide this area into subintervals. So we will try to draw some rectangles. If we draw a vertical line like this, and another vertical line such that we have a rectangle here. Now, area of this rectangle is width times height, or base times height. The base is part of this distance from 0 to 1. The height is f of the function at the midpoint of this rectangle. The idea here is that we are going to put infinite number of rectangles like this in this small area, such that when we find the sum of them, they will give me exactly the required area. We will imagine each rectangle as it is a segment, a vertical segment indeed. So the distance on x-axis covered by this area is from 0 to 1. This is the given. The first step is to find width of each rectangle. If we have n rectangles, so we should divide this distance from 0 to 1 into n. How that? Width of each rectangle is denoted usually by delta x. So we have delta x equal the distance from 0 to 1, which is 1, divided by n, where n is the number of rectangles. 1 is the horizontal distance. Horizontal distance. N is what? Number of rectangles. This means that these rectangles have the same width. How can I find height of each rectangle? If we consider the point 1 itself, what is the height of the rectangle which exists at 1? Of course, the height is f of 1. If we consider the point half, f of half is the height, because f of x gives us the vertical distance. So in this case, height of each rectangle equal f of 1 over n. But in fact, this is not the height of each rectangle. It's height of one rectangle. If I use I instead of 1, this gives us many rectangles. In fact, all rectangles in this area. Do you remember what is the area of the rectangle? Area of each rectangle is its width times its height. Area of each rectangle is its width times its height. This is the width and this is the height. Again, this is width of the rectangle. Now, if I want to cover the whole area, I need to find sum of these rectangles. So first of all, Sn, when we write Sn, we mean sum of these rectangles, sum of their area, of course, equals sigma from I equal 1 to n, f of I over n, this is the height, into 1 over n, this is the width of each rectangle. If I want to put it in the simplest form, it would be like this. F of x in my problem is y equal x squared plus 2. What is f of I over n? I think we should write again sigma from I equal 1 to n. Instead of writing f of something, it is something squared plus 2. So we have I over n squared plus 2. This part is f of I over n times the height, which is 1 over n. Do you remember? We have to take this 1 over n outside of the sigma, and we have to remove this bracket. It will be I squared over n squared. So if I want to reduce this, let us have the same sigma from I equal 1 to n. I have I squared over n squared times 1 over n. It is I squared over n cubed. We multiply this 1 over n times the first one. Again, we multiply this 1 over n times 2, which will give us 2 over n. In this case, we have sigma from I equal 1 to n, I squared over n cubed plus 2 over n. This will give us 1 over n cubed sigma I squared plus sigma from I equal 1 to n to 2 over n. But remember, this is constant. So when we find the sigma, we just multiply it by n. So this part will be 2 over n times n, which is 2. What about the other part? It will be 1 over n cubed. Do you remember sigma I squared? It is n plus 1, 2n plus 1, all over 6. Right? Plus, what is the sigma of this part? It's 2 over n multiplied by n. Constant times n. Now, we are going to simplify this form. How is that? Equals over 6n cubed. If I want to multiply them, let's first multiply n plus 1 times 2n plus 1. n times 2n is 2n squared, right? n times 1 is n. 2n times 1 is 2n. We have 3n. And the last is 1. This green part is instead of these two brackets. So don't forget that we should multiply it by n again. The result is going to be 2n cubed plus 3n squared plus n It is 1 times n. Now, I think that I can take 1 over 6 common factor here. We can divide each term by the denominator itself. 2 over 6 is 1 over 3 n cube over n cube cancelled, plus 3n squared over 6n cube is 1 over 2n, right? Plus n over 6n cubed is 1 over 6n squared plus 2. This is Sn. As I told you before, if we want to find the exact area, we should sum infinite number of these rectangles. So we find the limit as n approaches infinity, because if we increase the number of rectangles, in this case we decrease their width and we cover the whole area. We come very close to the exact area. So area equal limit when n approaches infinity to Sn. What is Sn? This is Sn. The limit as n approaches infinity, everything with denominator n becomes 0. So this becomes only 1/3 plus 2, which means 1/3 plus 6/3, that's 2, which gives us 7/3. This is the end of example 1. I hope you understand it. I know that it has many arithmetic simplification. We will meet in the second example. Goodbye.